Okay, last week we stopped over here, 6.1, example number 4. I asked you to go back and try. So take out your paper. Let's go through them very quickly. Part A, what did you all get? 3 sine 24 degrees. Oh, sorry. First one, 3 sine 24 degrees, what do you all get? Key it into your calculator now. 3 sine 24. So, yep, 1.2202. How many SF should we have? Before your rounding off, how many should we have? 5, huh? So I write off 5, and then I round off, become 1.22. Okay? Those who didn't try, use your calculator now and press. Okay, B. 4 tangent 34 degrees. Minus 2 sine 45 degrees. We have to do this step by step. Okay? So, we can choose to do this one first. Then we record down the value in 5SF. Then we do this, record the value down in 5SF. Then you minus, then you round it off. Troublesome lah. Quite troublesome lah. Okay? So what I prefer to do is I key everything into my calculator. But you must be careful because your trigonometry, everybody take out a calculator. Take out a calculator. Okay, press sine, S-I-N. And then you see an open bracket, right? When you have an open bracket, you should close bracket after you are done with keying whatever you need to key. Okay, so using this example, let us key in everything we see. Okay, so clear your calculator, press 4. Press 4 into your calculator. Then you press tangent. When you press tangent, you see an open bracket. What should you put inside? 34 degrees. Okay, so since your calculator is already in degree mode, you can leave it, it's good. So next we have minus 2 sine 45 degrees, close bracket. And what did you get? Answer will be 1.2838. 5SF, round it off. You get 1.28. Okay? Any questions? Anybody didn't get this? Okay, if all is good, then let's go on to part C. Cosine 57 degrees plus 13 degrees. Okay, cosine 57. Look, when I write in my working, I always put in the degrees when my angle is in degree. When I see students who don't leave it in degree, then I'll penalize you. Because if you don't write the little circle up there, you could be using other units. For example, radian, which you haven't learned yet. Okay, so I'm very particular about writing down the units, in this case degree. 57 degrees plus 13 degrees, that gives us cosine, how much is this? 70 degrees. Right, we work out whatever is in a bracket. And we get, from our calculator, 0.34202. So round it off, 3SF, 0.342. Okay? Now in part D, cosine 57 degrees plus 13. Okay, so key in your calculator, cosine 57 plus 13. What did you all get? Try, you need to press and practice. Part D, what did you all get? Nicola, what did you get? 13.544. Okay? Anybody else got the same answer? 13.544? Who was that? Who said yes? 13.544. Arfan, you got it, is it? The rest? Winnie Wong, what do you get? 13.544. And anybody got 0.342 or not? Okay, how many raise our hand? 0.342. Okay, so we see some of you get 0.342, some of you get 13.544. So which one is correct? Okay, the answer is 13.544. Okay, so what went wrong? Those students who got 13.544, you key in your calculator cosine 57 degrees. Okay, you got an answer, right? So you get 0.544. Then you add that to 13. Because you look at this. 13 got a degree or not? This 13 over here, is that a degree? No degree. This 13 is a whole number. It is a constant. So what we should have done was to find out what is this in the bracket first. Okay? So cosine 57 degrees, then you add 13. And you get 13.544. Round it off to 13.5. So this bracket I added in myself. I'm going to remove them now. So please take note of the difference between your part C and part D. Look at the way the question is phrased. The part C, 57 degrees plus 13 degrees, whereas in part D, it is cosine 57 degrees, you plus a whole number. Okay, that's the difference. Any questions? Then let us move on to 6.2, which is the next page. Flip over. So we have learned the basics of trigonometry. Today, we shall apply the ratios. Why do we say ratio? Anybody knows? Those who didn't come last week, you don't have your paper, right? Shouldn't you come and get it from me? Instead of sitting there. Who else? Anybody doesn't have 6.1 and 6.2? Okay. So why do we call it ratio? Tina, why do we call it trigonometric ratio? What are ratios? Something to something, right? So we can also express ratios as a fraction. For example, we say that 1:3 is the same as 1/3. Correct? So these are ratios. So why do we call it trigonometric ratios? What do you know about Tuakaso? Okay, let's start with TOA, okay? So TOA, what does this tell us? Tangent, whatever angle, for example, tangent theta equals to opposite over adjacent. This over here is our ratio. That's why we call it trigonometric ratio. And of course, we also have our CAH for cosine equals to adjacent over hypotenuse. And so, where we have our sine angle equals to opposite over hypotenuse. Okay, so these are ratios. We can use these to find unknown sides in right angle triangles. Okay, so sometimes we are given a right angle triangle, like in example 1, one right angle triangle, and you are only given one angle and one side. In this case, you are given 28 degrees, you are given 5 units for one side. Triangles have 3 sides, there are 3 angles. Right now, you are only given one side, one angle. Using this information, I can find the other 2 unknown sides. Where are the other unknown sides in example 1? We have over here AC, this is one unknown side. We also have AB, which is the other unknown side. Using trigonometry, we can find out what is the length of AC, what is the length of AB. Okay, so the steps are as follows. First, identify the side that is adjacent to the given angle. and which is the side that is opposite, and which is the hypotenuse. Okay, we have gone through this exercise previously already. So, in this triangle, example 1, which is the hypotenuse? AB. The hypotenuse of triangle ABC is AB. Okay, can we fill out the rest? Which one is the side opposite to 28 degrees? Kai? AC, very good. And finally, adjacent to 28 degrees. Now it must be BC lah. Okay, we have done step 1 already. This is the angle given. This is the side that is given. So the question wants us to find the length of AC. What is this AC? It is opposite, right? AC is opposite. What else do we already have? We have BC, which is given to be 5. So we also have adjacent. So look at this over here. Step 2, we are supposed to form an equation with the given side. In this case, it is BC. Form an equation with BC, which is 5 units, with the given angle, which is 28 degrees, and the unknown side. In this case, the unknown side will be AC. Okay, I need to form an equation with AC, BC, and 28 degrees. So what will my equation look like? AC is opposite, and BC is adjacent. Which trigo ratio should I use? So if you can't memorize, just write it down on the side. Your TOA, CAH, and SOH. Which one? Yeah, TOA. Because I have my opposite, I have my adjacent. I should choose this, tangent. Okay, so step 2, I am now going to write my equation. We know that it is tangent. This is our trigo function. It will always have an angle next. Tangent what? 28 degrees. Equals to? Tangent equals to opposite. So which one is opposite? AC. We don't know what that is yet, so that is our unknown. Over our adjacent. Which is our adjacent? BC, right? I can choose to write down BC, or I can write it this way, AC over 5. Okay, let's look at this carefully. Is this complicated? It is not complicated. We are able to find out from our calculator how much is tangent 28, right? All you need to do is to just press your calculator, then you get numbers already. And then on the right hand side, we have AC divided by 5. So I have a question now. To find AC, what would you like to do first? Do you want to use your calculator and press for the value of 28 first, or tangent 28? Or do you want to simplify, make AC the subject? You have two options. You can choose to use your calculator, then you end up with many digits over here. Then you find out what is AC, or you can straight away make AC the subject first. Which do you prefer? Why would you want to make AC the subject first? It's going to be more accurate, okay? So how do I make AC the subject? I can choose to multiply by 5 on both sides. When I multiply by 5 on both sides, very light, When I multiply by 5 on both sides, what do I have over here? I have 5 tangent 28 degrees is equals to AC divided by 5 times 5 is AC. So this one I'm going to get. AC is 5 tangent 28 degrees. So using our calculator, press 5 tangent 28 and you get 2.6585. Round it off. 2.66 units. Okay? So this is our answer. Yeah, you can do your cross multiply. When you say cross multiply, you will end up with 5 times tangent 28 equals to 1 times AC, right? Then 1 times AC is just AC. So it's the same thing. Okay, once you're done, then look back at your diagram. What information did you obtain? AC, right? So AC over here, we calculated is 2.66, or rather 2.6585 units. Does it look reasonable? Should our AC be smaller than BC? Yeah, it looks reasonable, right? Based on the diagram. Because it's a tiny angle. If this is a very big angle, then there is a possibility that AC will be greater than BC. So whatever you get for your answer, put it back in your diagram and see whether it makes sense or not. Any questions? Okay, then I want you to try example 2 yourself. Example 2, we are using the same diagram, okay? But this time your task is to find AB. So step 1 is already done. You need to do step 2, which is to form the equation. Okay, try it now. Tell me whether you use tangent, cosine, or sine. Once you do that, make AB the subject, solve. Ina, are you done? You finished already? Okay, then go on to the next example. If you need help, please raise your hand. Okay, let's look at example number 2. Now we need to find AB. AB is the hypotenuse. So our step 2 is to form an equation. Which trigo ratio or which trigo function do you use? Sine. Okay, let's see. Sine, what angle? 28 degrees is equals to our opposite, right? Opposite will be AC. You chose sine. Okay lah, you can lah. 2.6585 over hypotenuse. Okay, and that will be AB. Now some of you may find it strange because you did it another way. Don't worry about it first. Okay, so let's see. AB will be equals to 2.6585 over sine 28 degrees. Is your calculator? 2.6585 divided by sine 28. And I got 5.6627, round it off, 5.66 units. Okay, do you all get this? 5.66? Yes, no? Who got this answer? Raise your hand. Okay, the rest, what do you all get? What trigo function did you all use? Cosine. Okay, let's try cosine. Cosine 28 degrees equals to adjacent over hypotenuse. Okay, so adjacent is BC, so it's 5 over hypotenuse, which is AB. So we have AB is equals to 5 over cosine 28 degrees. That gives me 5.6628, which is round off to be 5.66 units. You get the same answer. There are two options you can use over here. So those of you who tried but didn't get an answer, do you know where you went wrong already? If you are not sure, please raise your hand. Okay. Then now, I give you exam tips. When you are faced with this question in the exam, what should you use? Sine or cosine? Because both get the same answer, right? So what would you use? Who will use sine? Why you choose sine? Huh? Why will you choose sine? No reason. Okay, anybody choose cosine? Why will you choose cosine? Sorry? Wait, what is it? BC is given already. Look. If I ask you to find AB and you choose to use sine, when you choose to use sine, you will end up having to use your answer from the previous part. Can you guarantee your answer was correct? If you are not very confident, right, then don't use it. Use cosine. Because cosine involves us using 5, which is given to you already. Involves 28, which is given to you. So if you had made a mistake in the previous part, don't worry. If you are careful, you'll still get the correct answer in the second part. Okay? As far as possible, use the numbers given to you in the question so that you don't have situations where you use your own wrong answer from the previous part. Okay? Now let's go on to example number 3. Part A, to find the length of BC. BC over here. What is this side called? What is this side called BC? It is adjacent to the angle 45 degrees. Okay? So we have our adjacent. That is our BC. And we have our hypotenuse, which is equals to 14. Okay, which is equals to AB, which is equals to 14. And we have our angle, which is 45 degrees. So what is the trigo function we should use? Natasha? Cosine? Okay, let's see. Cosine 28 degrees equals to adjacent, which is BC, over hypotenuse, 14. So now you have one equation with one unknown. Sorry? Oh, sorry, 45 degrees, yeah. Okay, so now we can write down what BC is. BC equals to 14 cosine 45 degrees. This is 9.8994. Round it off to 9.90. So that's BC. 9.8994. Okay? Then part B. Part B. We need to find AC this time. Okay, so AC, what do we call this? Which side do we call this AC? Hi, what's AC called? Opposite. Okay, OPP. And then we have our hypotenuse. We have our angle. Should I use BC for my answer? For my okay? No lah, don't use BC. Although if you are correct in part A, your answer for part B will also be correct. But let's not take the risk. Let us use hypotenuse again. Because we are sure that this is correct. Because it's given in the question. So all these are the information given to you. So my working will be, what trigo function should I use? OE? Sine? 45 degrees equals to opposite, which is AC over hypotenuse, which is 14. So AC equals to 14 sine 45. This gives me, again, 9.8994. Round it off, and we get 9.90 units. Okay? Hey, do you notice that the answers are the same? Possible or not possible? Why impossible? Because my triangle, obviously the AC should be shorter, right? But did I draw it to scale? I didn't draw it to scale. So look at this angle, 45 degrees. If this angle over here is 45 degrees, what do you think this angle is? How much is the other angle? 45 also lah. Because this is 90, right? So the angle BAC must also be 45 degrees. If these two angles are 45 degrees, what kind of triangle is this? It's an isosceles triangle. So your triangle looks like this. If you draw it properly, it looks like this. 90 degrees, 45, and 45. This is our B, C, and A. And since it's isosceles, BC must be equals to AC, which we have shown in our calculation. Okay? Yeah, correct lah. Next, example number 4. I will leave you to try it yourself at home. Do at home. Okay. Now I'm going to distribute the next set for 6.3 and 6.4. Okay, my computer is lagging.